right, so for question 9, we're talking about continuity over an interval, so we just have to check a lot of values instead of a single value. Which of these functions are continuous over 1 to 10? Well, this first one, we know this one's discontinuous when x equals 4, which is between 1 and 10, so this one's not continuous over 1 to 10 because the bottom is equal to 0 at 4. This one's going to be discontinuous at -4, but that doesn't matter because -4 is not in the region I care about, so this one's actually going to be an answer to the question. And this one, the natural log, we did want this one, exact one in class. If you plugged in, say 1, you would get a negative in the natural log, and that's not possible, so this one's also discontinuous, which means the answer is just 2. Okay, for 10, we're asking which of the following functions is not continuous over this interval. The interval is every real number, every possible number, so really this question is which one has a discontinuity. Well, we know polynomials are always continuous, so that's not the right answer. E to the x never equals 0. It's always a positive number, so that we never divide by 0 here. X squared plus 1, if we try to make that equal to 0, that means x squared would be equal to -1, which isn't possible, so C's out. And if we made x equal to 3, this would make the bottom one 0, so D does have a discontinuity at 3, which means it's not continuous. All right, 11 is the one where you need to know the unit circle. All right, we're looking for, again, continuity related to something with a fraction. So really we're thinking about when is the bottom of this fraction equal to 0. And if you know your unit circle, sine is equal to 0 at 0, pi, and 2 pi, and kind of it repeats in both directions, but those are the main ones that are going to be helpful for this problem. All right, so I would not be able to plug in 0. I would not be able to plug in pi. I would not be able to plug in 2 pi because that would cause me to divide by 0. Well, 0 is in the middle of these two numbers, so this one is out. This one is bookmarked by 0 and pi, but it's not actually equal to them. So for this one, this actually will work because it's just between 0 and pi, but not 0 and pi themselves. This one is actually trying to include 0 and pi, but we know we can't plug in 0 or pi, so this one's out. So the answer is just 2. All right, and then 12, we're trying to figure out the intervals where this function is continuous. Again, first of all, kind of just look at the rules themselves. Nothing's going to go wrong here with this exponential. Nothing's going to go wrong here with this polynomial. But here, something will go wrong. X equals 2 is a discontinuity. I'm just going to abbreviate like that. So x equals 2 is a discontinuity. And so that's the one thing we have to check is just the functions themselves. We also need to check when we change rules. So we change at 0, e to the 0 minus 1. All right, a few people made this mistake. Anything raised to the 0 power is 1. So that actually gives me 0. I'm also going to plug in 0 here. That gives me 0 over -2, which is 0. So this one actually works at 0. There's no discontinuity at 0. All right, what about at 4? So I plug in 4 here. I get 4. I'm going to plug in 4 into the bottom because that's what we're switching to. And I also get 4. So actually, both these switches work out fine. They're continuous, so there's only one discontinuity at 2. So my final answer, everything works up until 2, and then everything works after 2 as well. All right, so this would be your final answer. Basically, just 2 is the one discontinuity you have to worry about. All right, all the questions for 13 are pretty similar. You're trying to find this value that's going to make your function continuous. All right, like we've just been doing a bunch. We know something's continuous when those two pieces of the piecewise are equal. All right, that's not something you can solve, but what we can solve is we know this switch happens when x equals 2. So I'm going to plug in x equals 2. And this equation I can solve. So I'm going to subtract that right-hand side. I'm going to make it this. And I can factor that. And then I know that b equals 2. All right, so again, the main thing you're knowing is when you're removing discontinuities, those two pieces of the piecewise have to line up. And it happens when that x value, when that switch happens. All right, this one's the same idea. 3x plus 1 has to equal 4x plus 5. And where should that switch happen? Well, the switch happens when they're going to be equal to each other. So they're really this equation. We're just going to subtract and subtract. It's going to happen when x is -4. When I plug -4 into both of these, they're going to meet up, which would make the function continuous. 15 is a little bit harder because I can't just plug in x equals 1 from the start. If I plug in x equals 1 from the start, I'm going to get 0 over 0. Whenever you get 0 over 0, you pretty much always do the same thing. What you're going to do is simplify your fraction by factoring, and then cancel out that common factor. All right, so I couldn't plug in 1 into the full function, but I'm like, oh, what's happening at 1? I can cancel. Now plug in 1. And get 1/3. All right, so when I go to plug in 1, this function should be 1/3. So I'm just going to make c 1/3. All right, so basically this question is the same as finding the limit as x approaches 1 of that function. Because if I just replace c with that limit value, that's going to kind of fix that removable discontinuity that we have. And 16, kind of tedious. We've been doing the same thing. We set these things equal. This thing is happening when b equals 2. I can't plug in 2 right away because of this. So what I had to do is simplify first. That allows me to cancel. And now what I'm going to do is multiply both sides. Well, I guess before that, I would technically plug in x equals 2. And now multiply both sides by b and take a square root. Now, when you take the square root, technically you should get plus or minus 2. I didn't take off points if you just put positive 2, but technically the correct answer would be positive and -2 would solve this problem.